Hello students, I am Shubhashish. Today we are going to learn compound interest. Children, what is the most powerful force in this universe? How would you complete this quote? The world-renowned physicist Albert Einstein completed this quote with the word compound interest. When money is borrowed or deposited on simple interest, I equals to PNR by 100, then the interest is calculated evenly on the principal throughout the loan or deposit period. After the completion of this lesson, you will be able to know learning outcomes, to recall the concepts of simple interest, to understand what is compound interest, to able to find the compound interest through patterns and formulas and use them in simple problems. Keywords from this lesson: simple interest, compound interest, annual interest, half-yearly interest, quarterly interest, rate of interest, and time period. The formula to find the simple interest for a given principal is solution PNR by 100. Find the simple interest on rupees 900 for 73 days at 8% per annum. Solution: given simple interest I equals to PNR by 100, which is the formula. Next, we have the given values. The P, which is the principal, is given as 900. N is 73 by 65, 73 by 365, which is of 1 year. R, which is the rate of interest, that is 8%. So let's simplify 900 into 73 by 365 into 8 by 100. The two zeros cancels off. We are left with 9 into 73 by 365 into 8. 73 times 5 gives us 365. So the final value is 9 into 8, which is 72 by 5. After the division, we get rupees 14.4, which is the answer. Example: in how many years will rupees 2000 become rupees 3600 at 10% per annum simple interest? Solution. I is equal to 3600 minus 2000, which is equal to 1600. And that is the value of I. And we also have the formula, which is I equals to PNR by 100. Now replacing the value of I, 1600, equals to P, which is rupees 2000. N, the value is not given, into rate of interest is given, that is 10%. As we simplify, the zeros cancel. 1600 equals to 20 into n into 10. Further simplification, n is equal to, we send 20 into 10 to the left hand side, which becomes the division. So n is equal to 1600 by 20 into 10. Into 10 is 200, both the zeros cancel, n is equal to 8 years. Children, in post offices, banks, insurance companies and other financial institutions, there is another type of interest calculation on offer. Here, the interest accrued during the first time period, say 6 months, is added to the original principal and the amount so obtained is taken as a principal for the second time period, that is the next 6 months. And this keeps going on up to the fixed time agreement between the banker and the depositor. After a certain period, the difference between the amount and the money deposited is called the compound interest. Which is abbreviated as CI clearly. The compound interest will be more than the simple interest just because the principal keeps changing for every time period. We call the time period after which the interest is added to the principal the conversion period. For example, if the interest is compounded, say quarterly, there will be 4 conversion periods in a year every 3 months. In such cases, the interest rate will be 1/4 of the annual rate and the number of times that interest will be compounded is 4 times the number of years. In the case of simple interest, the principal remains the same for the whole duration, whereas in the case of compound interest, the principal keeps on changing as per the conversion period. The simple and compound interest remains the same for the first conversion period. Illustration. To find the compound interest on rupees 20,000 for 4 years at 10% per annum compounded annually and compare it with the simple interest obtained for the same. Calculating compound interest. Principal for the first year is equals to rupees 20,000 as given. Then let's find out the interest for the first year. We have the formula, which is PNR by 100. Let's replace the values. The principal interest we have for the first year is rupees 20,000. We substitute that, and the number of days or the number of years for the first year is 10 into 1 by 100. Now let's cancel, zeros and zeros cancel. The final value we have is rupees 2,000, and that is the interest for the first year. And the amount at the end of the first year, the formula is P plus I, which is principal plus the interest of the first year is equal to rupees 22,000. That is the principal for 2 years. Next, let's calculate the interest for 2 years. We already have the value. Let's substitute in the formula PNR by 100, where P is 22,000 into 10 into 1 by 100. The zeros cancel, and then we have the interest for 2 years as rupees 2,200. Now, in the same way, we find the amount at the end of 2 years. We add P plus I, which is rupees 24,200. Now that is the principal for the 3 years, rupees 24,200. Similarly, we follow the same steps, substituting that into the formula PNR by 100. P value is given, N and R is given by 100. Zeros and zeros cancel. 242 into 10 is rupees 2420, and that is the interest for the 3 years. Amount at the end of 3 years is P plus I. After adding, we get rupees 2,000. We get rupees 26,620. That is the principal for 4 years, rupees 26,620. And then the interest for 4 years. Clearly, let's put the values in the formula PNR by 100. P is 26,620 into 10 into 1 by 100. The zero cancels. We have the final answer for the interest for the 4 years is rupees 2,662. Amount at the end of 4 years, P plus I, the final answer is 29,282. Now that we have found all the interest for the 4 years, the compound interest for 4 years is A minus P, which is the amount at the end of the 4 years value, minus P, which is the principal which was given at the beginning, which is 20,000. So rupees 29,282 minus 20,000, and the answer is 9,282, which is the compound interest for 4 years. Now let's calculate the simple interest. Recall that simple interest I is equals to PNR by 100. Here P, like it said, P is equals to rupees 22. P is equals to rupees 20,000. N is the number of years, is equals to 4 years. And R is the rate of interest, which is 10% per annum. Clearly, we have the values. Let's substitute in the formula I equals to PNR by 100 by replacing the values. P is 20,000, N is 4, and R is 10 by 100. Zeros and zeros cancel. 200 into 4 into 10, and we have the simple interest rupees 8,000. What we observe from the calculation of compound interest is a repeated multiplication by the factor 1.1 as 20,000 into 1.1, 22,000 into 1.1, 24,200 into 1.1, comma 26,620 into 1.1 for 4 years. We also note that the compound interest, which is rupees 9,282, grows faster and is clearly more than the simple interest, which is rupees 8,000 obtained. When the time period is longer, the above method is time consuming. So, to save time and to find the amount and the compound interest easily, we have a formula as explained in the following illustration. Illustration 2. To calculate the amount and the compound interest for rupees 1000 for 3 years at 10% per annum, compound annually. We have the flow chart showing 10% interest being compounded annually. This leads to the pattern for amount as P 1 plus R by 100 for the first year. In the same way, P of 1 plus R by 100, 1 plus R by 100 for the second year, for the 2 years. Next, we have P 1 plus R by 100, 1 plus R by 100, 1 plus R by 100 for the 3 years and so on. In general, A equals to P 1 plus R by 100 to the power of n for the nth year. So, here the amount after 3 years. A is equals to 1000 of 1 plus 10 by 100 whole to the power of 3. So, we substitute the values equals to we take the LCM over there, we get 1000 of 110 by 100 whole cube. 110 by 100 written 3 times, the zeros cancel, so we are left with 11 multiplied 3 times. 11 into 11 into 11 is equals to 1331. And so, the compound interest is equal to A minus P, which is the answer, rupees 331, which is the compound interest. The following formula will help calculate the compound interest easily for the following time periods. First, when the interest is compounded annually, we have A is equals to P of 1 plus R by 100 whole to the power of n, where A is the amount, P is the principal, R is the rate of interest per annum, and n is the number of years, and we shall get the compound interest as Ci is equals to amount minus principal. When the interest is compounded half yearly, we have A is equals to P of 1 plus R by 100 whole to the power of 2n. When the interest is compounded quarterly, we have A equals to P of 1 plus R by 100 whole to the power of 4n. When the interest is compounded annually, but the rate of interest differs year by year. We have A equals to P of 1 plus A by 100, 1 plus B by 100, 1 plus C by 100 and so on, where A, B and C are interest rates for 1, 2 and 3 years respectively. When interest is compounded annually, but the time period is in fractions, say A of B by C years, we have A is equals to P of 1 plus R by 100 whole to the power of A of 1 plus B by C plus R by 100. Use of calculators is permitted for lengthy calculations and also to verify answers. Example. First one. Find the compound interest for the data given below. Principal is equals to rupees 4,000, R is equals to 5% per annum, N is equals to 2 years, interest compounded annually. Solution. Amount A is equals to P of 1 plus R by 100 whole to the power of N, which is the formula. Now let's substitute the values in that. So P is 4,000 of 1 plus R is 5 by 100 whole to the power of N is 2. Now let's solve this further. Let's take LCM over there. We get 105 by 100. 5 20s are, 4 20s are, 5 20s are and 5 21s are. So 4,000 into 21 by 20 into 21 by 20 because it was whole to the power of 2. Zeros and zeros cancel. 2 times 20 is 40. 2 times 10 is 20. So 21 into 21 into 10, and the final answer is A is equals to rupees 4,410. Next, we are left with finding the compound interest, which is A minus P, which is equals to 4,410 minus 4,000, which is equals to the compound interest is rupees 410. Second example. Principal is equals to rupees 5,000, R is equals to 4% per annum, N is equals to 1.5 years, interest compounded half yearly. Solution. As per the formula, amount A is equals to P of 1 plus R by 200 whole to the power of 2n. Substituting the values, P is rupees 5,000 of 1 plus R is 4% per annum, which is written 4 by 100 whole to the power of 2 into n is 1.5 years, which is nothing but 3 by 2. Further simplifying, 2 and 2 gets cancelled over there. LCM is applied, 104 by 100 . 25 times, 26 times. So 5,000 into 26 by 25 is multiplied 3 times because whole cube. Let's simplify it further. 25 times 200 gives us 5,000. 25 times 8 gives us 200. So that is 8 into 26 into 26 into 26 by 25. We further simplify this and we get the answer 5,624.23. And lastly, we have the compound interest, which is amount minus principal is equals to 5,624.23 minus 5,000, and the compound interest is rupees 624.23. Third example, principal is equals to rupees 30,000, R is equals to 7% for 1 year, R is equals to 8% for 2 years and compounded annually. Solution. As per the formula, amount A is equals to P of 1 plus A by 100, into 1 plus b by 100. Now let's substitute the values. P is nothing but 30,000 of 1 plus 7 by 100, which is the rate of interest for the first year, and 1 plus 8 by 100, which is the rate of interest for second year. Simplifying it further, 30,000 into LCM over here, 107 by 100 into 108 by 100. $30,000 into 107 by 100 into 108 by 100. Simplifying it further, we get A is equals to rupees 34,668. Compound interest is equals to amount minus principal is equals to 34,668 minus 30,000. And the final answer for the compound interest is rupees 4,668. Fourth example, principal is equals to rupees 10,000, R is equals to 8% per annum, N is equals to 2 and 3 by 4 years, interest compounded yearly. Solution. As per the formula, amount A equals to P of 1 plus R by 100 whole to the power of A by 1 plus B by C into R by 100. P is 10,000 of 1 plus R is 8 by 100 whole to the power of 2. 1 plus B by C is 3 by 4 into R is 8 again by 100. Further simplifying it, 4 times 2 gives us 8 and 3 into 2 is 6. So 10,000 into, over here LCM is applied, which is 108 by 100. 27 by 25 after further simplification is what we get. And over here we have 100 plus 3 into 2 is 6. So 100 plus 6 is 106 by 100. 2 times 50 gives us 100 and 2 times 53 is 106. So 53 by 50. 10,000 27 by 25 whole square into 53 by 50, where 27 by 25 is written 2 times into 53 by 50. Let's cancel. 0 and 0 cancels out. 5 times 200 is 1000. 25 times 8 is 200. And further simplification can be done, and we have the final answer for the amount as 12,363.84. And we are not done yet. We have the compound interest, which is equals to amount minus principal is equals to, where the amount is 12,363.84 minus principal is 10,000. So the compound interest is rupees 2,363.84. Points to remember. When the interest is compounded annually, A is equals to P of 1 plus R by 100 whole to the power of N. When the interest is compounded half yearly, A is equals to P of 1 plus R by 100 whole to the power of 2N. And when the interest is compounded quarterly, A is equals to P of 1 plus R by 400 whole to the power of 4N. When the interest is compounded annually, but the rate of interest differs year by year, A is equals to P of 1 plus A by 100 of 1 plus B by 100 of 1 plus C by 100, where A, B, C are interests for 1, 2 and 3 years respectively. When the interest is compounded annually, but the time period is in fractions, say a of b by c years, we have a equals to p of 1 plus r by 100 whole to the power of a 1 plus b by c into r by 100.